Let's start with gamma and beta function. So I have already discussed in my previous class of improper integral. So what is improper integral and how can I define the improper integral? So in this class I am going to explain two special type of improper integral, and the first one is called the gamma function and the next one is beta function. These two functions is actually two improper integral, and here I am taking these two function with some restriction of its parameter so that the function will be convergent. So let's start with the function first of all, and then I will explain some problem from here. So what do you how can I define the gamma function? So gamma function, this is an improper integral which is written as, suppose I am writing it at gamma of x. And what is gamma of x? 0 to infinity e to the power minus x into x to the power and this is into dx, right? Sorry, this will be gamma n. So gamma n equals to e to the power minus x to the power n minus 1 dx, and here this integral will converge when n greater than 0. That means this improper integral will have a unique value if n greater than 0, right? So this is the definition of gamma integral. And the next one, beta integral. There are actually so many properties of gamma function. The first one is gamma 1 equals to 1, gamma of n plus 1 equals to n gamma n, right? Or you can write this as gamma x plus 1 equals to x gamma x, where x is a real number. Now when x lies within 0 to 1 in this range, then the formula will be gamma of here gamma of x and sorry, this will be gamma of x gamma of 1 minus x. This is equals to pi cosec pi x when x lies within 0 to 1. That means x takes the fractional value. So these are the basic properties of the gamma function, and this is when n belongs to capital N, natural number, then this is our n factorial, right? This is our n factorial. And when n is any real number, then for any real number x, we will have this formula. Here x belongs to any real number r. So that's it, the basic formula corresponding to gamma function. And similarly gamma half, the value of gamma half equals to root pi. You can verify easily using this formula, right? Now the next one is beta function. So these all are the properties of gamma function. Now I will tell you the properties of beta function. So first of all I am writing the formula for beta function, right? So here beta function, now I am defining first of all beta xy. So beta xy equals to 0 to 1. Here one thing you just note that for gamma function the limit starts from 0 to infinity, and for beta function it starts from 0 to 1. And this is our beta xy. Beta xy means t to the power x minus 1 minus t to the power y minus 1 dt, right? And this improper integral, this is an improper integral, and this improper integral will converge for xy greater than 0. This is the condition of convergence. 0 to 1, t to the power x minus 1, 1 minus t to the power y minus 1 dt, right? This is our beta xy, and there are some properties of beta function. Beta xy, this is equals to beta yx, symmetric function. You can just interchange this x and y, then you will get the same result. The next one, the second property is the relation between beta gamma function. Beta xy equals to gamma x gamma y, the most important relation, by gamma x plus y. This is the relation between beta function and gamma function, right? Now the next one is another form of this beta function is beta xy. This is the most useful format. Beta xy equals to 0 to pi by 2, right? Here 2, 0 to pi by 2 sine to the power 2x minus 1 theta into cos to the power 2y minus 1 theta d theta. This is the another version of beta xy. So when you are given some trigonometric function, then you should use this formula, and when it is some relative to some algebraic format, then you should use this formula, the first one, right? So it's actually depend on the given condition and given format of the function. And now after some deduction of this, now I am writing the another format of this formula. To boost up our calculation, right? So the another format will be another format. Just look at here. Suppose you are given 0 to pi by 2 sine to the power p theta and cos to the power q theta. So this is equals to half beta of p plus 1 by 2 and q plus 1 by 2, right? So this is the most useful formula. If you are given some problem in this format, actually you are given the problem in this format, right? Then you can directly use this, right? So that's it, the all properties of the functions. Now we will start some problem from here. Now look at our first problem. The first problem is find out the value of this 0 to infinity e to the power minus x and x to the power 3 by 2 dx. The very easy problem. So first of all, you should look at the format of the given improper integral. Starts from 0 to infinity, so it is obviously gamma function, right? You should determine whether the function given is beta or gamma. So this is our gamma function. Now compare this with the standard form of gamma function. This is our standard form, 0 to infinity e to the power minus x to the power n minus 1 dx. Now compare the given improper integral with this, then we will have n minus 1 equals to 3 by 2. So n minus 1 equals to 3 by 2. N equals to 3 by 2 plus 1, that means 5 by 2. And this is actually equals to gamma n, right? This is actually equals to gamma n. So here the value of n is 5 by 2. So it will be gamma 5 by 2, right? And I have already told you that gamma x plus 1 equals to x gamma x. This is equals to x gamma x. So you can write this as 1 plus 3 by 2 according to this formula, right? Now 3 by 2 gamma 1 plus 1 by 2, we can write this as this way. So 3 by 2, 1 by 2 gamma half. Now it will be 3 by 4 into gamma half. Gamma half means root pi. Therefore our answer will be this. This is the answer. Right, a very simple problem. And so we will go for the next problem. So now look at our next problem. So here the next problem is integrate 0 to pi by 2 root tan x dx. Find out the value of this. So since the limit starts from 0, it is pi by 2, so it is obviously our beta function, right? This function is our beta function. And root tan x means we can write it root sin x by root cos x dx, right? Now this is equals to integrate 0 to pi by 2 sine to the power half x into the next one will be cos to the power minus half x dx. Now I have already told you that if you are given the improper integral in this format, sine to the power p, in my, just look at my formulas which I have just told you. So here the formula was 0 to pi by 2 sine to the power p theta cos to the power q theta d theta. This is equals to beta, half beta of p plus 1 by 2 q plus 1 by 2, right? So it will be half beta of half plus 1 by 2, that means 3 by 2 by 2, and the next one is minus half plus 1 by 2, right? Therefore now it will be half beta of 3 by 4 1 by 4, right? Now I am using the relation between beta and gamma function. So gamma 3 by 4 gamma 1 by 4 by gamma of 3 by 4 plus 1 by 4. Therefore this is equals to half. So gamma, it will be gamma 1, and gamma 1, the value of gamma 1 is 1, right? And the upper portion, that means the numerator, will be gamma of 1 by 4 into gamma of 1 minus 1 by 4, right? And the denominator, this will be gamma 1 means 1. Now in our next step, gamma, here look at this portion. If I am taking x equals to 1 by 4, then it looks like this gamma of x, gamma of 1 minus x, and here x lies within 0 to 1. That means according to the formula it will be cosec pi by 4, right? And cosec pi by 4 means root 2. So it will be root 2 by 2. That means 1 by root 2. So this is the answer. Therefore, sorry, just here the formula was pi cosec pi by 4, right? So it will be pi. So there is pi. So the answer will be pi by root 2. This was our formula. You can check this formula in my first part of my lecture. Now I will go for the next one. The next problem, a very interesting problem, 0 to 1 x to the power 2016 and 1 minus x to the power 2017 dx. Now find out the value of this. A very interesting problem, and just look at this problem and compare the beta function. It will be our beta function, right? It will be our beta function if I am comparing this with the beta function. So we can write this as, after comparison we can write beta of xy. So xy means here actually just compare this with the compare this with this format, that is 0 to 1 x to the power m minus 1 1 minus x to the power n minus 1 dx, right? So this is our beta of mn. I am writing this function in terms of beta mn format because we are given here x is the variable, so that's why here I am taking in this format with respect to this parameter mn. So if I am comparing this with this, then m minus 1 equals to 2016, that means m equals to 2016 plus 1, that means 2017. So it will be 2017 and the next one will be 2018. Just adding one with this and with this. So beta of this, now I am using the relation between gamma and beta function, right? I am using the relation between gamma and beta function. So what was the relation? Gamma of 2017 gamma of 2018 divided by gamma of 2017 plus 2018, right? So this is equals to 2016 factorial into 2017 factorial, because we have already told you gamma of n plus 1 equals to n factorial if n belongs to n. This by, and this will be 4035 gamma of 4035, and now gamma of 4035 means it will be 4034 factorial, right? So this is the answer of the question. So that's it. Now I will go for the next one. The next problem, and this is also the most interesting problem, 0 to 1 dx of 1 minus x to the power 6 to the power 1 by 6. So first of all, look at the limit 0 to 1, so that's why it will be our beta function, right? This is our beta function. Why this is beta function? Because it starts from 0 to 1, right? Now here we should use some substitution. Without using substitution, it is a little bit of difficult. So we shall use a suitable substitution, and here I am using the substitution as x cube equals to sine theta. So x cube equals to sine theta means it actually gives 3x squared dx equals to cos theta d theta, right? And from here dx equals to cos theta by 3 sine to the power 2 by 3 theta d theta, and the limit would be 0 to pi by 2, right? Limit from 0 to pi by 2, and now putting the value of this of x. So x cube means sine theta, that means it will be 1 minus sine square theta, that means cos square theta, and cos square theta to the power. So the next one will be, just look at this, the upper portion will be cos theta and the lower portion will be so 3 cos square theta, that means cos to the power 1 by 3 theta, and sine to the power 2 by 3 theta, right? 2 by 3 theta d theta. Now in our next step, 1 by 3 of 0 to pi by 2, and it will be cos to the power 2 by 3 theta and sine to the power minus 2 by 3 theta d theta. This is equals to 1 by 3 into 1 by 2 gamma of this plus 1, right? 2 by 3 plus 1 by 2 gamma of minus 2 by 3 plus 1 by 2 by gamma of 2 by 3 minus so 2 by 3 minus 2 by 3 plus 1 by 2. So actually in our previous step it will be 1 by 3 into 1 by 2 of beta p plus q by 2, that means 2 by 3 plus 1 by 2 and minus 2 by 3 plus 1 by 2, right? Now after that we will have this step. Now from here we will calculate it. Now I am calculating this portion. So here 1 by 6 and this portion will be gamma 5 by 6 and the next portion gamma 1 by 6 and the lower portion will be, just cancel out this, and the lower portion will be gamma of 1, right? So 1 by 6 of gamma of 1 minus 1 by 6, we can write this as 1 minus 1 by 6 and gamma of 1 by 6, and here 1 by 6, and look at the formula, this formula 1 minus 6 is equals to pi cosec pi x when x lies within 0 to 1. So here x equals to 1 by 6. 1 by 6 lies within 0 to 1. So it will be pi cosec pi by 6, right? Pi cosec pi by 6. So that means it will be pi by 6 into cosec pi by 6. So cosec pi by 6 means 2, right? So it will be pi by 3. Therefore the value of this integral will be this. This is our answer, right? So that's it. This is my today's class. I hope that this class will help you a lot in your competitive exam. And so here first of all you should do the maths and okay, so first of all you should do it, and first of all determine whether the given function is beta or gamma, right? Whether the given function is beta or function. If beta function, then corresponding to that the formulas, you all know the formulas, and for corresponding to the gamma function. So the most important thing is choosing its suitable substitution. Just look at this problem. Our suitable substitution was x cube, right? Suitable substitution x cube equals to sine theta. This is the suitable. I am using the word suitable. There are so many substitution. If you use most suitable substitution, then it will decrease your time, right, to solve the problem. So that's it in my today's class. Well, we will meet soon in my next video. Thank you.